Hello, I'm Chris Athanas. I'm a KMP developer. And today we're going to be getting into more about how to program from the ground up. We're going to get into abstract classes. Ooh, abstract classes. Oh, yeah, tech support. They got the part, but they don't have the tool to install this thing to get rid of that damn portal. So eventually, I'm sure we'll get that thing closed, but not today. So here we go. So abstract class. An abstract class. This is one of the most confusing things that I had come across when learning how to program. And it's kind of central to the COP style, the COP style, which, I'm going to give the COP style some credit because it does go fast. Okay, it is faster than what I'm proposing with this why this is bad. It does go fast, and we'll talk about it here. So this is me, and I just came back to programming after taking a break and wondering what happened to the OOP that I thought would be coming through Smalltalk, the standard, all the standard modeling messaging stuff. No. Okay, here we go.
What's this? What? This car. This stupid car.
What's this cop car? It was class-oriented programming stuff.
Where's the Cadillac?
Throw the statics out. I'm just throwing the statics out.
Where's the caddy?
Where's the Smalltalk with all the messaging and all the stuff?
The what?
The OOP, man.
The Cadillac we used to have. The Bluesmobile.
Yeah, that thing was sweet.
Traded the Bluesmobile for this?
You traded it? You traded the OOP for the cop?
No, for a microphone.
A microphone?
Okay, that makes sense.
Okay, I can see that.
Yeah, I can see
What the hell is this?
This was a bargain.
I picked it up at the Mount Prospect City Police auction last spring. It's an old Mount Prospect police car. They were practically giving them away.
They're just giving the COP away, man.
Well, thank you, Al. The day I get out of prison, my own brother picks me up in a police car.
Pathetic. I come back to programming, and what have you guys done? You just see with classes and you change the name. Oh, okay. I was expecting to have a little easier time, but no.
You don't like it?
No, I don't like it.
No,
Car's got a lot of pickup.
yeah, C++, yeah, it is performant as hell. I'll give you that. I will give you that.
It's got a cop motor, a 440 cubic inch plant. It's got cop tires, cop suspension, cop shocks. It's a model made before catalytic converters, so it'll run good on regular gas.
It's got all the cop stuff, man. It's got procedures. It's got statics. It's got abstract classes.
What do you say? Is it the new Bluesmobile or what?
Fix a cigarette lighter.
Yeah, get those statics out of here somehow. We'll talk about it anyway. All right, now enough silliness. Let's get into it. Okay, the big idea. Can we use this class structure? Let me get over here so we can have a dual side by side. Can we use this class structure? Because when they were creating C++, when the guy was creating it, all he knew about was classes. They didn't have this abstract class. So he had this thing of interfaces. He's like, can we use the abstract class kind of like an interface? Okay, so because confusing terminology alert. Okay, so the whole big deal is we can create many different types of objects with the same method signature, different types of classes of objects with a subclass with the same method signature, so we can call different implementations of its methods based on its class. That's the whole thing. And they use this confusing terminology of abstract. So I suggest forgetting the word abstract and substitute the phrase general category. When I was first learning the abstract programming concept, I kept confusing it with the abstract concept in art, abstract concept in philosophy, and other meanings of the word, and derivatives. Because I was coming from, I'm not just a technical person. I'm coming from all kinds. I'm just a curious person, a Boy Scout. I wanted to know all the stuff. And what I ran into is a lot of people who are very good at this stuff, who are specialized, didn't know about that other stuff. So I would get confused. I would like to engage them in conversation, and they would be like this guy. They were treating me like this guy right here. So I'm like, this is Booga Yinko. This is me asking about what does this deal with the statics and the class oriented style of using, you're basically doing procedural with these inside these objects. And these are the guys going like, no, we're making performance stuff here. And this is the kind of person I was dealing with quite a bit. So let's look at this.
Hey, what's that? I want Jim to see that. Wow, where'd you get this?
What's an abstract class?
I was trying to break into Protovision. I wanted to see the program for their new games. Hey, wait, Tim, I'm not through yet.
Remember you told me to tell you when you were acting rudely and insensitively? Remember that? You're doing it right now.
Yeah. With this naming stuff, they're acting rudely and insensitively. With this naming stuff, okay. And the way they communicated this idea was extremely poorly done. All right, so many people who attempted to explain the abstract keyword to me were likely unaware of the other meanings of the word and confused me and other people, because I'm not the only person who's had this problem. It's very common. So when you think of the word abstract, just a substitute general category. That's all it means. And boy, do they make a big deal about this bullshit. Excuse my French. Okay, function signature. All this means is the function name plus the parameter types, the string, plus the return type. That's all they're talking about here. It's also called a method signature. Method and function, using them interchangeably. It's a definition of the method. So we're talking about this thing here. Hey, what are you doing? Hey, what are you doing? Okay, let's go here. All right. So we're talking about this particular thing. How am I doing here? This thing running out of memory. Hold on here. All right. I had to go restart. I have had so many problems with this markdown stuff. There's actually a memory leak, and I found quite a few bugs in the markdown stuff, which hopefully they'll fix. But anyway, so I had to just ran out of memory and had to restart. So basically, we're talking about the same idea as an interface. This abstract thing is the same kind of idea as the inheritance idea, is the same kind of idea as the interface idea. It's the same idea. And the reason that we gave it a different name was how they're using it in the code. That's it. How they're using it. So they wanted to make sure that how they were using it and what the capabilities are reflected what their name is. So an abstract class is like the interface, except that now you can have default implementation. So you can have these things. So you can have a little thing. Instead of having just the interface with just the signature, now you can have a definition of a function. Ooh, wow, okay, whatever. I mean, I understand why they did it, but it's still blasting this out to people without giving the full context of why you're doing this stuff, which they did for many years. And that's caused so much confusion because people totally interpreted this stuff in two different ways. They were trying to do the OOP route, and they're doing this procedural slapping objects into procedural methods thing. So there's two, and these people were using the same language and using the same constructs, and extremely difficult to communicate because people would get like, it's this kind of person right here. It's this person right here. It's this guy. It's this guy. It's this guy. And trying to deal with these two guys together. These two guys. And I'm just trying to go like, what is all this, guys? What is all this? He's like, there's computer. This guy's super procedural, high performant. This guy's, hey, we need to go to the next level. This is bullshit. All right, so that's what that's about. So, okay, some examples. In the abstract class file, like, okay, then this is a made-up example. Abstract file has a single method named view, right? Right here, view. And it does not implement how a view has a function. This one has no implementation, right? Just like an interface. An attempt to instantiate a file object will. This is something that people you can't instantiate an abstract class. It's like, okay, you can't it can't instantiate a general idea of a thing. And I'm going to be very pedantic right here, and I wish the teachers I was getting this great knowledge from, just do this for me. I said, okay, programmer, create a conceptual file. Create the general idea of a file. Ask the computer. It's like, okay, computer goes, well, what do you mean? What kind of file? Compiler error. It's like, I don't know, just make one. Make an abstract class of file that doesn't have a view method. And if you called it, well, all it has is a show name. Okay, we could instantiate that, but that doesn't really make any sense. It's just abstract idea of file. Okay, so it says, I don't know, just make one. Make sure it's the idea of the file. Which one, though? I don't know. The concept of file, just to instantiate the concept. It's like logically not possible. So that, do you understand? It's like, you cannot have the concept of just like animal, right? Give me, make an animal. Well, what do you want? A cat, a dog, a cow, an insect? What do you? No, just give me an animal. All right, well, here's a slug for you. Well, that's not what I wanted. Okay, you can't give the concept of animal to somebody. You can give them the concept of animal, but you can't give them a concept. Okay, that's the whole thing. The file is a class. The file is a class. The file class is an abstract class, and the class photo, class Excel doc, class memo, these things down here are the concrete implementing classes. So that you can actually create instances of these objects, but you can't make one of these. So this is just a way to categorize things. Like this is a file, an Excel document's a file, a memo is a file, an Excel. Here, let's go see. So here is the big chart right here. I'm gonna try and open it up here. Let's see if I can open it up if it lets me. This is I've been having these bugs with this thing. It says syntax error, but there is no syntax error. So let me see if I can get it here. All right, here we go here. So I just dumped that same text in there. So something's wrong with GitHub's rendering. I don't know what it is, but sometimes it works and sometimes it doesn't. Okay, whatever. Anyway, here it is. So we have this abstract class that is the general concept of file. And the general concept of file is going to have a name, right? So you have this thing that says you have to define a name. So you name it, you define it here. You say override the name here. So this Excel document, and then when you when it creates it, right? When memory is allocated and wants to initialize it, it calls the super, which just assigns this name to this variable here, which is actually stored here. It's not stored here. It's stored here in the object, right? So super means the super class. Call the super of the constructor. So if it's in this thing constructor, it's going to call the constructor here. So if you just see super by itself, all it means it's calling this thing here. That's all it's doing. Ooh. And then you have another method view. So this is saying I expect, so an abstract method. So I'm expecting, this is another thing. So this thing is abstract. So this is like another thing. It's like, this is basically saying I'm expecting, and I use the word abstract. I don't know why they did this, but it just makes the same thing as expecting here. Just this is like a different, I know this is super confusing. They keep using the same word for multiple things, and it's extremely annoying. So anyway, so this is basically saying I expect to see a method defined when you actually extend a class that creates a concrete implementation. I expect to see a show name I'm expecting the view here to be implemented. So I'm expecting this view to be implemented here. And here's one for here. Here's the view for Excel doc. It just happens to print out Excel doc. Okay, well, this might, open up a whole application, open the Excel like this. But that's the idea. And then here's the show. Here's the print here for this one. The view, the view right here. So view, and then here's the view here. The view here. And so if you go to, okay, we'll keep going. Let's just keep going. I don't want to go too far off the cuff here. All right. I'm trying to explain this in a way that makes sense and not over-explain it, because it's such a simple concept, but they over make this thing into this most amazing thing ever, and it's not. It's just a way of arranging your code. That's all it is. All right, so here we have the abstract file I just took the exact here. The UML is right here. So I just put it right here in the code. So you can see how this maps out and where everything goes. And you're going to have to study it. I'm not going to go through it line by line, but you can study it and see here. And one of the things I wanted to point out is this method of extending these base classes is extremely fragile. And here I have an example of why it's fragile. Right here, this memo. So in this memo, let's say the team is, some new member of the team comes along and says, okay, you have to add this memo thing to our system. And this new member, maybe some of the old members have gone, there's not much documentation, very common. And he comes in and goes, okay, I'll just extend the memo here. But the show name, which normally just displays the file name, I'll just use it to do the names of the people. So now it's using the addressee names here, right? The names of the addressees of this thing and not the file name. So it's already kind of breaking the idea. It's like, okay, that's not really what we intended this file system for, but we got to shoehorn this thing in so you can see how if you have 3 or 4 levels of this kind of stuff happening, new members of the team coming in, people adding stuff, deleting stuff, and extending things where they really shouldn't be. This is why they talk about the fragility. This is why this inheritance thing, they took it way too far. And imagine having this thing that's another thing that's extending memo, and another thing that's extending memo, and then instead of doing show name, they're doing something from this one, something from that one, and it just gets super brittle. So you can't change it anymore. The brittle means you can't change it. So if you go try and change something up on the top, it's going to break everything down below. And everyone's going to be mad at you because you just broke everything. It's like, well, everything's super constrained together. I can't change anything. I just have to extend it again. Which is why you get these applications, these massive trees of extensions. That's why they were like, okay, inheritance is probably a bad idea. Maybe 2 levels deep, maybe 3 tops. Do you see why? And it's only to structure the current understanding of the system, not add on to it. That's where that whole reuse thing went crazy. So I have the live code example here to go into, and you're going to have to experiment and play with this. It's not, you're not going to, I didn't get it right away, but these, I gave enough here so you can understand the concept and where things can go wrong pretty quickly, right? So that, and I'm trying to simplify this down to the easiest to understand case for that's like, oh, okay, I understand what you're talking about here. And this one's in Kotlin. And the IDE, the reason I put this all in the IDE is because you can go in there and see where things are. So if you click on something, it'll highlight where this is. And you can kind of see how things are structured just by kind of clicking around on stuff. Like this font here, it's implemented right there. It's implemented, or it's being, this is an implementation of this right here. So this is really handy to see how things are structured. And what's being overridden, and you can see how this gets super complicated super fast. So you're overriding things here, other things are overriding things here. It's changing them kind of the meaning of what it means to say show name. Like both Photo and Excel doc, they don't override the show name. It just uses the abstract implementation, the abstract classes implementation, the general implementation, which is just print the file name. But this is like, no, we're going to use that. We're going to change that. Now you have to know that there's been a change in the what the meaning is. When you do show name on a memo, oh, it's going to print out the Chris to Bob instead of the file name. So this is how it can get super complicated really quickly. And I also wanted to get the full diagram, how all this stuff's put together, because I actually asked people for this, and they couldn't come up with it, or they came up with it wrong, or it was wrong. Because they didn't fully understand it, and they were just trying to be a big shot. They were trying to be this guy. They're trying to be this guy. They thought that they really wanted to be this guy, but they're this guy, and it's super annoying and really hard to deal with. And just get ready for it. If you're going to be getting into computers, there's going to be a lot of Aspies that just honestly they think they know, but they just haven't seen enough yet. So they are almost Dunning-Kruger all over the place, except for a few narrow areas where they're excellent, and you definitely need them around for that. So it's like a, good with the bad, right? So here's the abstract class file, and I've just mapped it out here, exactly here. And then you have abstract method view right here, abstract method view right? And it's this idea and expects to have an implementation, and this thing implements it here, right? So the Excel doc down here, Excel doc, where is it? Excel doc. Excel doc implements this view function right here. So there it is. Boop, there's the function. And if you're, and then it, you know, has the same thing here. The method show name is so we have the show name here. It's defined here. Abstract string file name. It's expecting it to be in defined down here, which it is. Each one of these things is overridden. We should have called it defined, or I don't know. They just go. This is what they call override. So it's like you're overriding this abstract method. It's just okay. You're defining it here. It's like this is expecting it here. This is defining it. This one actually has it defined, but you can override it. Like you can this one right here. This method overview was overridden, right? In the Excel doc, right? Excel doc. So the method view was overridden here. So it created it in the class, not in the superclass, not in the abstract class. And you can have massive chains of these things. Now you can only inherit in Kotlin and all these modern Java and other C#. You can only do one chain. You can only have one class you can inherit from. So at least they got that, and we'll go into why multiple inheritance is a bad idea in the next one. Or did I already talk about that? I don't know. I can't remember. Let's see. What did I just talk about? Okay, so there's that. So instantiates, boop, 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 boop. Oh yeah, so polymorphism. And yeah, okay, we'll get into the multiple inheritance here in the next couple episodes. But yeah, so I've really tried to make this diagram very actually what's going on and in the simplest case possible. And I'm a very visual person. People have actually tried to verbally explain this to me. Are you kidding? Don't even try that stuff. It's like these guys. If you just do the thing, it's in his brain, right? It's in his brain. It's all visually mapped out completely like this. But he's trying to verbally tell me these things using metaphors that aren't supposed to be extended. Like, come on, man. All right, so we're going to get into metaphor, some polymorphism next. I did want to talk about show this one, this little video about encapsulation and how this kind of is another way of visualizing this. Brian Will's pretty good, but he's also one of these guys. So it's sometimes difficult to deal with his stuff. He gets a little bit pedantic and aspy, but good stuff anyway. Here we go.
Encapsulation. The idea of encapsulation is simply that the fields of an object and instance should only be read or written by methods of that instance's class. So say in the cat class, the principle of encapsulation says that the number of lives field of a cat object should only be read and written by methods of the cat class, not by methods of any other class or by any other code. So when we're writing code outside of the cat class, outside the methods of that class, the only way we're supposed to be interacting with the fields of any cat object is by invoking methods of the cat class, and then it is the methods themselves which may directly read and write the fields of cat. Say that this here represents some instance of a class with 3 fields and 4 methods. If we want to read or write one of these fields, we should not do so directly from outside the object. Only the methods of the class should be directly reading and writing these fields from outside the class. Externally, we only interact with the fields.
So this is the visibility stuff. This is the visibility.
Methods of the class should be directly reading and writing these fields from outside the class. Externally, we only interact with the fields indirectly by invoking the methods.
Right, so this is the true OO style, not COP style. This is the true OO style. So you're supposed to, I mean, you can still do this in COP, but the true OO is only through the methods do you get to the values of the variables. You can't just go in there directly. So COP lets you go in there directly.
The thinking here is that when you create a class, the methods you give that class encapsulate, they encompass all of the knowledge of what is meant to be done with the data that makes up that data type. The hope is that if we strictly follow this principle, our code will end up neatly and cleanly modularized, thus allowing us to easily make changes, to add features, and to fix bugs.
That's the push we're going for.
If you fail to adhere to this principle of encapsulation, data in your code easily ends up getting read and written from all different places in code.
That's the COP. So he's talking about the COP style.
The result is what we call spaghetti code which is extremely difficult to understand and therefore very difficult to fix and modify.
It's a thinking of spaghetti code because you got all kinds of things instead of just everything inside doing its own thing to its own self, its own objects, and then sending messages to other objects. You have things all coming in all different angles, and you have to know every time you do that. You have to remember all the other ones that are accessing it directly because any change here is going to break all their stuff because they're accessing it directly. Let's say change the name, You have to make sure all the other places are changing the name. To change the functionality, it's to make sure all those places that are doing the direct access have the functionality change as well. Good luck tracking it all down.
When adhering to the principle of encapsulation, we commonly make a distinction between public and private members of a class. The public members of a class, we say, are visible anywhere, meaning that it's okay to access them from outside their own class. The private members, in contrast, are the members which are only meant to be accessed by methods of the same class. When you follow the principle of encapsulation strictly, all fields should be kept private. Methods, on the other hand, may either be private or public. The methods only used by the class itself, you would keep private, but those methods which are used to interact with the class from outside the class, you of course would make public.
And we're going to get into visibility in the next section.
Some object-oriented languages are more strict about enforcing the principle of encapsulation than others. The static languages actually prevent private members from being read or written outside their class, while the dynamic languages typically do not.
Okay, so that's implementation detail, not important.
The second important principle of object-oriented programming is called inheritance. The idea of inheritance is simply that some data types, some classes, may overlap, such that one data type has all the same stuff found in another. When our programming language has a mechanism for inheritance, this allows us to formalize these relationships. So for example, say we have three classes, one called animal with the members A, B, and C, one called mammal with the members D and E, and another cat with the members F and G. For our purposes here, it doesn't matter which of these members of the classes are fields and which are methods. In any case, if we link these classes together by inheritance, such that cat inherits from mammal and mammal inherits from animal, well, what that will mean is that the mammal class will automatically inherit all of the members of the animal class and F and G. For our purposes here, it doesn't matter which of these members of the classes are fields and which are methods. In any case, if we link these classes
I didn't do anything.
together by inheritance, such that cat inherits from mammal and mammal inherits from animal, well, what that will mean is that the mammal class will automatically inherit all of the members of the animal class, and in turn, the cat class will inherit all of the members of the mammal class, including the members which mammal itself inherited from animal. So here you can see that the cat class has the member E as defined in mammal, and also has the member B as defined in animal. So even though when we wrote the cat class we only specified that it has members F and G, because we specified that cat inherits from mammal and mammal inherits from animal, then cat has the members A, B, C, and D. This is automatic inheritance. If our language didn't have any kind of automatic inheritance mechanism, then to get the same effect, we would have to explicitly define the members A, B, and C in all three classes, and the members D and E in both mammal and cat. Doing this would not only be bothersome, but potentially error-prone, if we want to make sure that the definitions across the classes stay exactly the same. With an inheritance mechanism, we don't have to worry about accidentally forgetting to include a member in cat or giving it the wrong definition. Now, an important thing to get straight here is the terminology for the relationships between classes. Here in this example, we would say that mammal and cat are subtypes of animal, and cat is a subtype of mammal. And conversely,
or subclass. They use the words interchangeably.
We would say that animal is a supertype of mammal and cat, and mammal is a supertype of cat.
Or superclass, same thing.
Alternatively, instead of saying subtype, we could say descendant, and instead of saying supertype, we could say ancestor.
That's rarely rare. It's mostly parent-child.
So, for example, animal here is an ancestor of cat, and cat is a descendant of animal. And then, a bit confusingly, we also have the terms parent and child. A parent is a direct immediate ancestor, and a child is a direct immediate descendant.
Those are all the same. Those are all same ideas.
So here, for example, animal is a parent of mammal, and mammal is a child of animal, but animal is not a parent of cat, nor cat a child of animal, because the inheritance in that case is not direct, only indirect through mammal.
I mean, they are very pedantic. He's being pedantic right here, but people use these terms all interchangeably.
The real question now is, what's so great about inheritance? Why have some classes be subtypes of others? Well, the most obvious use for inheritance is when we're modeling real-world objects, as we presumably are doing here with these classes animal, mammal, and cat. In the real world, you do have things which effectively form this kind of hierarchy, where a cat is a kind of mammal, and a mammal is a kind of animal. So when we create classes to represent those three things, it makes sense that we put them in a hierarchy of inheritance. If a cat...
Right, for that particular static case, if that's all we're modeling is those things, those make sense. But if you start to extend the model out, you have to reconsider all these decisions.
Truly is a type of...
Which is the knowledge work, right? This is the knowledge work. It's like figuring out this stuff and how you take a problem space and split it up so we can handle it easier. And hopefully extend it, but not necessarily. Like, just get the case that we're doing the best we can, and we'll change it when we need to. That's it.
Mammal, just a more specific kind of mammal, then it will need all the same features that the mammal class has, as well as features specific to cats. Like, for example, all mammals eat and sleep, so it makes sense that the mammal class might have methods called eat and sleep for eating and sleeping. But cats also do some things which only cats do, not all mammals, like meow and purr. So if you had a meow method, you would put that in the cat class, not the mammal class. Now, in practice, the vast majority of classes programmers make don't really model real-world objects. The classes which programmers make tend to represent much more abstract sorts of things.
Because they're doing this class-oriented programming stuff, where they have everything's a manager, and it's just dealing with somebody else's data. It's just using the same old procedural style, structured style programming techniques, except they're putting this wrapper called object-oriented around it, which isn't really object-oriented at all. We've already discussed this.
When dealing with abstract entities, it's often not so obvious when one type is truly a subtype of another or not. However, when you can successfully identify such relationships and create a proper inheritance relationship in your code, you may end up saving yourself from duplicating functionality in one class that already exists in another.
Right. It's not a general case thing. It's if what you're working on the problem space makes sense to do it this way, do it this way. But if it doesn't, don't.
In fact, it's fairly common when working with an existing program that a new feature you might add can be successfully implemented by simply taking an existing class in your code and extending it.
Yeah, that's the thing that people get in trouble with. You can do that limitedly. You can do that a little bit. But if you make the habit of it, your code base will be a mess very soon. And that's why people said, okay, forget this inheritance stuff. Let's try to the composition, which is why composition is huge. But there are classes of problems that this makes sense for.
That a new feature you might add can be successfully implemented by simply taking an existing class in your code and extending it, that is, producing a subtype of that class. When this works well, it allows you to focus on just writing the code for the new functionality, not having to duplicate already existing stuff. It's very common, though, for learners to get the misimpression that they should be using inheritance all over the place. This is not the case. You need to think before you use inheritance. The simple rule you should keep in mind when thinking about using inheritance is to ask yourself, is the relationship between these two classes really an is a relationship or a has a relationship? In a proper inheritance relationship, instances of the child class can be considered more specific versions of the parent class. So, for example, a cat is a kind of mammal. That's an is a relationship, so it's a proper use of inheritance. In other cases where you might be tempted to use inheritance, the true relationship is not an inheritance relationship, but a composition relationship.
So this is talking about using interfaces instead of having a long string of one inheritance chain. Using these interfaces, like, do you have the ability to eat? Do you have the ability to walk? Do you have the ability? Do you implement the walking? Do you implement the eat interface? Do you have a method called eat that accepts this type and then returns this type? Do you have a method called walk that accepts this type and returns this type? What walk doesn't matter. It's in the simulation, right? It's representing something else, right? So it's eat represents what? We take one digit of food, 1 point of food. You know, if you do walk, you get to move one square on the map wherever, that kind of stuff.
For example, a car is composed of many parts, including the steering wheel. So if we have a car class and a steering wheel class, then it makes sense that the car class has a steering wheel field. That's a has a relationship because it calls for composition, not inheritance.
Right, so it has a method called jive. So change gear. Has a method called steer left, steer right. That's it, right? That's all the ideas. This is a little bit played out thing. It's kind of hard to think of this way. It is somewhat helpful, but it's been a little bit deprecated. So anyway, we're going to get into polymorphism next. Yay, polymorphism. It's such a neat word. It's so different, by the way. So different. It means something's different. It's so different. It's so different than abstract methods and abstract classes and extending things. Oh, okay, whatever. All right. I'm slightly annoyed. Give me a like and subscribe. We'll continue on this journey and helping you out, trying to wade through this muck of all these weird, strange terms. Yeah, it's odd, and it's all this. It's all referring to the same stuff. It's okay. Then what problem space are you working? How are you going to structure your problem? These are all tools and ways, but they're not end results. And people thought they were end results, and that's what it got so nuts, man. All right.